This is number 8 in the series, Model Steam Engines for Beginners. In this one I'd like to discuss common problems found with model steam locomotives, particularly steam locomotives that haven't been used for a while. The problems are always the same, the main problem being stuck ball valves. If the engine's been laid up for a while and all the water drained out of the boiler, the residue that's in the water, or what's left of it, causes the stainless steel balls to stick in the valve. This model steam locomotive has its own rolling road, and it's very useful for bench running. Much better than putting the locomotive on blocks, because the running gear is at working height as it would be on the rails. And it's also good for compressed air testing, which I'm about to do. First of all, you have to decide which is the best way to introduce compressed air into the boiler. With this being a 3.5-inch gauge locomotive, the best thing to do is to take the roof off. This makes working on the loco simple. You can get at all the connections. Here are the footplate controls. First of all, the reversing lever. This selects forward and reverse gear. This is the blower valve that directs a jet of steam up the chimney to draw the fire. This is the pressure gauge. This is the regulator, or the throttle. The water gauge is self-explanatory. It shows the level of water in the boiler. This is the water pump bypass valve. More about this later. And finally, the whistle valve. The whistle valve is mounted on the steam turret, and this is the best place to connect a compressed air supply. So here you see me removing the pipe that connects the steam from the turret to the blower valve. So now I can connect my air line directly to the turret. Make sure that the reversing lever is in mid-gear position, that's in the centre. That way, if the regulator leaks, the engine cannot move. Fill the boiler with compressed air up to the working pressure. In this case it's 80 pounds per square inch. What we're looking for here are leaks from the fittings. The boiler's had a hydraulic test, so that won't be leaking. After looking at the backhead fittings, have a look at the safety valves. It is essential that these do not stick. Pull the centre part with a pair of pliers whilst the boiler has pressure in it, to make sure that the balls are lifting from the seats. Once you're happy with the safety valves, move the reversing lever into forward gear, lock it in position with the locking handle, and open the regulator slowly. Sometimes when a steam engine's been laid up for a while, the slide valves are reluctant to sit on the port faces, so you may have to quickly open the regulator a couple of times to snap them into place. In this case everything's fine, and off goes the engine. But it's not going anywhere thanks to the rolling road. Try pulling the reversing lever back a notch. This is called notching up, and it makes it so that the engine uses less steam, because the travel of the valves is limited as you notch back towards reverse. The next thing to look at is a reliable water supply to the boiler. This is the crosshead boiler feed pump, a very simple device, a simple lift pump. In this case both of the balls were stuck and I had to dismantle it to fix it. What it does, it feeds the boiler, but you have a bypass valve that allows the water to return to the tank. This bypass valve is mounted in the cab. On the right hand side here you see it, and here I'm closing it. By closing it, water is pumped into the boiler, and as you can see the bypass in the tank stops. When you open the valve, the bypass starts running again. And the idea is to get the bypass valve set so that the pump replenishes the water in the boiler as the steam engine uses it. In the tank at the other side is the manual boiler feed pump. This again is a simple lift pump operated by a handle and allows you to manually fill the boiler if all else fails. Initially, just like the crosshead pump, this didn't work, but once I filled the side tanks with water, as this is immersed in water, the water soon worked its way through and both the stainless steel balls worked fine. As this is a coal-fired engine, when running an engine of this type under steam, it's essential to replace all covers on top of the water tanks before running. Any ash or grit you can really do without in the water tanks. And if you overfill the boiler whilst running on compressed air, just open the water gauge blowdown valve and let some water out. Although this is a very simple steam engine, it wasn't built by a beginner. It was built by a very experienced engineer. With the exception of the water gauge, all the fittings are made by the engineer. They aren't commercial fittings, including this wonderful mechanical lubricator that really works well. It will over-oil the cylinders as they nearly always do, but that's not a bad thing. It's better having too much oil than too little. When doing a lot of locomotive running, as I have done in the past, you get used to looking at the chimney for that ring of oil. When the ring of oil disappears, it's time to worry. So just to recap, this is a great little engine built by a very experienced engineer, not a beginner, and it runs really well indeed. The problems I had are basically the usual ones, normally caused by the engine being in dry storage for some time. The problems being, the crosshead pump ball valves were sticking, the hand pump ball valves were sticking. And worst of all were the safety valves. The stainless steel balls were firmly stuck to the seats in these. They may have freed off by themselves with the heat of steam raising, but I much prefer to check it on compressed air first. As far as I'm aware, this engine was finished around 2005-2006. That's when the original boiler certificate dates from, so things like the gland packings are all in good order. When working on very old steam engines, often you have to dig out the cracked and dried old valve packing and replace it. Thanks for watching, I hope it's been of some use to you.